Good evening, everyone. Thanks for tuning in tonight with Torch Talk. I'm Tig Tucker, here with
Ark Anderson,
and we will be talking about shielded metal arc welding, also known as stick welding. It is one of the oldest and most used welding process. Today we will be talking about the pros and cons of electrodes.
but first off, what does an electrode look like?
Glad you asked.
Wow. This is a 718 rod. It's a high strength, high quality, smooth bead quality rod. Line! But it's more difficult to strike an arc with this than other rods compared to.
Next on the list is our 6010 electrode. This is deep penetration, which makes it really good for welding dirty, rusty, and thick material. It's a standard for pipe welding, root passes. The disadvantages are that it's challenging for beginners because of the aggressive arc and how it's only DC power source.
1611 is just almost close to 1610 counterpart, but it can be used with AC and DC power units, which makes it very versatile. But unlike its stepbrother, it has a very rough weld appearance.
Next up on our list, we have the 6013 rod. It has the ability to be used in all positions. It is smooth and a suitable arc for beginners. Its main cons: shallow penetration, chance for slag to be trapped, and it is not as stable or sturdy as a 7018 rod. One of our final electrodes we have is the Weir Shield 15CR MG. It provides an impact-resistant deposit that hardens under pressure. Its main purpose is to weld earth-moving equipment like crushing hammers and excavators.
But it is very difficult to machine and requires careful preheating. In 1880, early arc welders used carbon electrodes.
In the early 1900s, coated electrodes developed by Strominger and Kjellberg in Sweden.
In 1927, a more economical way of coating electrodes was developed, and it became more practical and widespread in the US.
Now, folks, it's time to ground your clamps. We're getting into the number classification system by Brandy Sparks.
Lineup that we have. We're just going to go over the AWS classification system. The E represents the electrode that we'll be using. The 7D represents the tensile and KSI. The number 1 here is going to represent the position in which we'll be holding that electrode. 1 will represent a flat, horizontal, vertical, or overhead. And for 8, I have the type of coating and current that we'd be using. Thursday, we're a little cloudy with some rain, but that's okay because that just means that we're meeting the lower temperature that the impact requirements are asking of us. The H4 represents the hydrogen, and it's less than 4 milliliters that are in there. And for our final Saturday, we're closing out with meeting the requirements just to absorb the moisture test. And back to you guys.
Thank you, Brandy Sparks. Now we'll be diving deeper inside of the electrode now. We're going to move on to SMAW. So we got our good friend here, Buzz Fluxman, who's been in the industry for quite a while with us. Hi, I'm Buzz Fluxman, the man right here. So I'll be trying to lay a bead in front of him to show him how it's really done.
Bombastic side eye.
All right, guys, here we are with the finished product. I think it looks pretty solid myself. Buzz, what do you have to say on it?
Well, I can see a couple of problems here. When you first started out, your bead was too wide because you're too hot. So we need to check your amps. Check your amps on your machine. And then I see where you sped up, which flattened out your weld. So what we're going to have to do is check the amperage on the machine, and then we want to measure our plate because we're running too thin a plate for that amperage.
I thought any bead you could just run and be fine.
No, sir.
What does that have to do with anything?
No, sir. You have to adjust your amperage and which will control your travel speed also, depending on your base metal and how thick it is. For that amperage, you need a 1/4 inch plate. And all we have here is 3/16 plate. So we're going to have to cut that amperage down and move at a consistent speed.
Buzz, how do we find the correct electrode size? You said mine was way too thin here. What's going on?
Yeah, okay. Well, if you can't tell just by looking, and later on you'll be able to do that, you take it, set it on your rule, and you can see that this is a 1/8 rod. Okay, hold on. One more thing. I got one more thing here. When you're watching your puddle, you don't want that puddle any wider than 3 times the width of your rod. Now it can be a little smaller, but you don't want it no bigger than that. Okay. It would be like having a rod on each side.
What changes does that make to the puddle?
Your speed can change it. Also your amps can change it. But mainly your speed and your arc length.
So you're telling me I want this to be 3 times the size?
No more than 3 times the size.
Can I see that? Inner rod diameter is going to be 3x. Alright, so now that I see that, I'm going to try to visually see 3x the size here. How are we looking now with this new one?
Okay, let's check it. See, now that's within parameters.
That looks about 3x right there.
Thank you with Brandy. It'll come handy. Hey guys, in today's kitchen, we're gonna go ahead and talk about some low hydrogen electrodes. Today I have some 7018 rods sitting in the oven because they are moisture sensitive. I do want to keep them in the oven at about 250 to 300 degrees. Since I opened them, if they're not open, I keep them in the room. Now, if they do get exposed to moisture, I can rebake them, but it has to be between 500 to 800 degrees depending on the manufacturer's specs, and only for about 1 to 2 hours, no more than that. So here we have some electrodes that we store at room temperature, mostly cellulosic and rutile. Some cellulosic electrodes are like the 6010, 6011s. They do require a little bit more moisture for art characteristics compared to low hydrogen electrodes. So they don't necessarily need to be baked or rebaked. As far as the rutile electrodes go, those are like the 6013, 7014s. Those are moderately sensitive to moisture. So if there is moisture that is absorbed in it, we do have to rebake them at about 250 degrees to about 300 degrees for about an hour. We keep them in this dry area away from moisture. And if it is a humidity in the atmosphere, which we don't really have, we can go ahead and put them in the oven from about 100 degrees to 150 degrees. And this is how we store and bake our electrodes.
I am here with Buzz Fluxman. Unfortunately, we face the sad reality of losing all of our audio, so you get to watch me and Buzz yap session. So here I am, Rodney Filler, to fill in the gap, no pun intended. So what are the different types of fillers, and what do they entail? It's basically how the molten puddle and the slag behave. So fast freeze electrodes, like 6010, 6011, solidify really quick. It makes them great for vertical and overhead welding because the molten metal doesn't drip or sag down. They produce a deep penetrating arc, perfect for root passes and pipe working. The bead can look a little rough and require more cleanup than others. Next, we've got fast fill electrodes such as 7024. They're basically opposite of the fast freeze because the puddle stays fluid much longer and deposits a lot of metal quickly. They're ideal for flat and horizontal welds mostly on thicker plates. They don't really handle out of position welding well because the puddle is so fluid. Then we got fill freeze group. So they're basically the middle ground, which would be 6012, 6013 rods. The puddle solidifies at a moderate rate, making them easier for beginners to control. They can be used in basically any position and have a much smoother bead appearance. They're pretty good on sheet metal or general fabrication too. Finally, we got low hydrogen electrodes such as 7018. They're designed to minimize moisture and hydrogen in the weld to prevent cracking. So it's mostly on more high strength steels or thicker joints. They produce a pretty strong ductile welds with a smooth bead and must be kept dry. That's why they're always in that oven like our baker showed you guys. So to sum it up, fast freeze for penetration and position welding, fast fill for heavy flat welds, fill freeze for general use, and low hydrogen for critical high strength applications. Also, a side note, we unplugged the sound guy's career, so if anyone's interested, please contact our local newswork.
And that's all from Torch Talk tonight. Reporting live from inside the Ark. Good night, everyone.